Alright guys, this is the second half for 11.5, so if you haven't watched the first half, please do that first. So you should have just watched a video that talked about the gold bar at Fort Knox and how to use density equals mass over volume. So using that as your example, I want you to go ahead and try to do this one on your own. And here we're trying to find the mass of the concrete to the nearest gram. Okay, but I want you to know that this is in inches, this is in cubic centimeters, so just like we did before, you're going to have to change this to centimeters before you do any calculations. So go ahead and do that, and then we'll go over it. Alright, so when you go through and do this, you first want to convert all these to centimeters, so that's what I did here and here. And then you want to go ahead and find this, think it as a cylinder, so volume equals pi r squared h. You should get 948,906. Okay, well, you know the density now, so we plugged in the 2.3 in for density, and we know the volume because we got it from right here. And then when we did a little bit of math, you should have gotten 2,182,485 grams. All right, let's look at another example here. Okay, so we have these drawers here. It says we're building a 6-foot tall dresser, so we know the height here is 6. You want the volume to be 36 cubic feet. Okay, so the volume needs to be 36 feet cubed. What should the area of the base be? Give a possible length and width. Well, this would be a rectangular prism. So the volume equals area of the base times the height. Okay, so volume here is 36. So 36 equals area of the base. I'm just going to call it B, and our height is 6. So divide by 6, divide by 6. 6 equals area of the base. So if the area of a base is a rectangle and the area of the base is 6, I don't know, we could have like a 2 by 3 foot, or 3 by 2, or 1 by 6, or 6 by 1. Those would all be possible dimensions. All right, let's look at example 5a. It says these two are similar. Okay, find the volume of cylinder B. Now we've done this for similar figures before, but we did it with area, not volume. Okay, so the first thing I want to do is I want to find the scale factor in one dimension. Okay, so when we're flat, so it would be 3 to 6. So the scale factor on a dimension is 3 to 6 or 1 to 2. Okay. Now, I'm going to volume, and volume is always cubed. Okay, so that's the exact same thing as I'm going to do here is cubic. So I can say my scale factor in 3D is 1/2 cubed, or 1 cubed over 2 cubed, which is just 1 over 8. Okay, so now I can set up a proportion. So I can say 1 is to 8 as 45 pi is to x. So x equals 8 times 45 pi. And 8 times 45 is 360. And that's centimeters cubed. All right, I want you to try this one on your own, and then we'll go over it. All right, so if you go through here, you're going to find the dimension, or you're going to find the scale factor in one dimension, which is just 1 over 4. Okay, I got that by this is 3, this is 12, 3 over 12 reduces to 1 over 4. Okay, now I want to know what it is in 3D. Since I'm in volume, which is 3-dimensional, so I cube it. So 1/4 cubed gives me 1 cube over 4 cubed, which is 1 over 64. And then I can set up a proportion. So 1 over 64 is the area of the small over the, the volume of the small over the volume of the big. Cross multiply, you should get 24 meters cubed. All right, so this is our last one. And here we're going to try to find the volume of this composite solid. Okay, so when we do this, notice this is a triangular prism. So we want to take the volume of the triangular prism, and then we're removing this right here. So I'm going to do minus the volume of the square prism. Okay, and if I do that, then I would get the volume of this composite solid. All right, so let's first find the volume of this square cylinder that cuts through it. Okay, and this is the part that we're going to subtract because we're like taking it out. So if I look here, I know it's kind of hard to see. There's what looks like this, which tells me that all four sides are equal. Okay, and so this is just, think of this as like a box, so we could just do length times width times height. So to find the volume of the prism, it'd just be 3 times 3 times 6. Okay, 3 times 3 is 9, so this would be 54. Okay, now we have to find the volume of the triangular prism. Okay, so the big outside, this. Okay, so let's first look at the base. Let's find the area of the base first. So this is the base. And I'm just going to forget this hole is cut out from it. Okay, so if I have 10, 10, and 10, if I want to find the height of this, remember, I'm just looking for the area of this triangle. Right? I would cut this. And when I cut that, this would be 5, 5. And if I use what I know about special right triangles, I could say this is 5 square root of 3. Or you could do Pythagorean theorem to find it yourself. Okay, so the area of this, the area of the triangle, is 1/2 times base, which I want the whole base, times the height, which is 5 square root of 3. Okay, so if I put that into my calculator, I get roughly 43.3. Okay, so that's the area of my base. So the volume of this prism is area of base times the height. Okay, well the area of my base is right here. And remember, my height is just the distance between my two bases. So this would be the distance between my two bases. This would, whatever. Well, that's right here. Okay, so the height is just 6. So 43.3 times 6, you put that in your calculator, you get 259.8. So to find the volume of this composite solid, I would just take 259.8 minus 54, and you'd get roughly 205.8, and don't forget your feet cubed.